I hope you're doing awesome today. Let's get right into this problem set because there's a lot to cover and these videos I want to try to keep them short. So this is the problem set for Module 5, Lesson 10, and our objective, what we're trying to do today, is we are trying to find the area of a rectangle that has fractional sides. In other words, what we're trying to do right now is figure out what happens if a rectangle has a side that's not like a full length, that's a fraction of a side, like 12 and a half, right? How can we find the area of that? So in order to get into this, there are a couple things we really need to remember. The first is, how do we find the area? Actually, even before that, the first is, what is area? Area is what? So let's take this beautiful rectangle that I'm about to make here. No, let me try again. Here's my beautiful rectangle. No, let me try again. Take 3, y'all. Bam. All right, there's my rectangle. The area is everything inside. So we've been talking a lot about volume, right? And that's the amount of space that can go inside a 3D object. Area is the amount of space that fits in a 2D object. So I want you to think of a piece of paper, of a basketball court, of the floor, right? The area is just all the space that's covered by that flat object. But if you think about each of those things I just said, none of them also have height. They all have a length and they all have a width, but none of them have a height. That's the difference between area and volume. So here we're looking for area. And all of those things, let's take a piece of paper for example, we'll say they have a length. And one thing that's important about them when they're rectangles is that this side and this side will always be equal. They'll always be the same number. They'll always be the same, right? And same with this side and this side. So if this blue side is 12, this blue side will also be 12. This pink side is 13, this pink side will also always be 13. Pink and blue don't always have to equal each other. They can, and when they do, it's a square. But pink always has to equal pink, blue always has to equal blue. So if I know the side of this blue, I know the side of this blue. If I know the side of this pink, I know the side of this pink, all right? And in order to find area, what we do is we multiply the width times the length, right? So here's my length, here's my width. Now, that's how we find area. We multiply the width and the length. So in this case, with this rectangle, it's got a length of 12, so my pink is going to be 12. And remember, if this side is 12, this side will also be 12. And it has a width of 15. So remember, if this side is 15, this side will also be 15. Right? So in this case, I could do 15, bam, times 12, and I will be able to find my area. I actually want to put a hold on that for just a second, and I want to move on to the other side of this question. If you read all the way through this question, it said a rectangle has a length of 12 and a width of 15. Find the perimeter and the area. So we figured out how to find the perimeter. How do we find, we figured out how to find the area. How do we find the perimeter? Perimeter is the amount of space around the outside, right? So if we think of a basketball court, if you walked the edges of the basketball court, you're walking the perimeter of the basketball court. So here is perimeter. I'm going to draw it. Going this way, going this way, going this way, going this way. And I got the perimeter. You're not going inside the basketball court. You're staying on the edges, and that is the perimeter. So to find the perimeter, we actually add the length twice. So length plus length, because as you'll notice, I walked the length twice, and I add the width twice. Plus width, plus width. This width and this width. Another way to think about this, since this is length plus length, it's actually 2 times length plus width plus width, 2 times width. So in this case, and I'll show you for this, right? For this case, length is 12, right? So it would be 12 plus 12 plus the two widths, 15 plus 15. 15 plus 15, that'll be 30. 12 plus 12, that'll be 24. Oh, hello Stokes. And 24 plus 30, that'll be 54. Right? And again, like I said, you could kind of do just 2 times the length plus 2 times the width. So if we look at that, 12 times L or 12 times 12, sorry, 2 times L or 2 times 12 would be 24. And 2 times the width would be 15 times 2 would be 30. And look at that, we get 54 again, right? So that's how we find the perimeter. We find the amount that goes around the outside. Let's look at the area, okay? Area, it says width times length. So you're not actually using this side or this. You're only using one length and one width. And you're going to multiply them, that looks like a 5 now, and one width. And you're going to multiply them to each other. And I actually want to go back to something we used to do when we would do this. I want to know if you remember doing this, right? When we would be multiplying, we would break apart the number we were multiplying by the place value. So in this case, 15, we would break into 10 and 5, and 12 we would break into 10 and 2. And then we would multiply and add all together. So 10 times 10, that's 100. 10 times 5, 50. 10 times 2, 20. 2 times 5, 10. Add them all together. 100 plus 50 is 150. Plus 10 is 160. Plus another 20 is 180. And so my area would be 180. Now, the reason that I went back to this model is for what we're going to do next, for our objective of trying to find an area of a rectangle with fractional sides. So stick with me on this, all right? So here we have a rectangle with a length of 12.5 feet and a width of 3 1/4 feet. First, it's asking us to find the area. So again, let me draw a rectangle here. Let me draw a rectangle. Boop, boop, boop. Close enough, right? For now, we're going to say it's close enough. We're going to say length of 12.5, and so I'm going to make this my length. And remember, if this side is 12.5, the opposite side will also be the same, will also be 12.5. So this is 12.5. This is 12.5. And for my width, it says my width is 3 1/4. So I'll make this 3 1/4. And I'll make this, also remember, going to be the same, 3 1/4. Now, the area of the rectangle, remember, is length times width. It's length times width, or in this case, 12.5 times 3 1/4. Now, how can I do that? Well, I want to go back to the area model we talked about earlier. Let's break this up, shall we? Let's break 12.5 up into, and I'm going to go back to my colors, into 12 1/2. And I'm going to break my 3 1/4 into 3 1/4. 3 times 12 is 36. 3 times 1/2 is 1/2 plus 1/2 plus 1/2, or 3, oopsies, come on, 3 halves. 12 times 1/4 is 12 over 4. And 1/4 times 1/2. Remember, when I'm doing multiplying a fraction by a fraction, I multiply across, right? So when it's multiplication, when it's addition, it's something different, right? But when it's multiplication, 1 times 1 is 1, 4 times 2 is 8. And now, just like I did with this one, when I then had to add all of these up together to get 180, I would need to add 36 plus 3 halves plus 12 fourths plus 1/8. Now, yes, that does take a while, and yes, you might have forgotten how to add all that together. And if you did, that's fine. Come to office hours. That's what I am here for. But this is what you would do. This is how you would get started with finding the area, right? We would break apart the 12.5 into 12 and 1/2. We'd be able to do this multiplication, and then we would add up. We'd have to add all these up. And again, come to me if you're struggling with that, all right? Come to me and Miss Andrea. We're here, all right? Really quickly, let's go on to the perimeter. Remember, perimeter is length plus length plus width plus width, or in this case, I'm going to do this one first just because it's here, already in that color, 3 1/4 plus 3 1/4 plus the lengths, you guessed it, 12.5 plus 12 1/2. So we're actually going to be going over this and talking about it during the concept development portion of our day today. But if you have any questions about it, if you need some help with it, I hope this video helps you, right? And again, if you get stuck with the whole adding fractions things, that's come to office hours type of thing going on, all right? I love you. I miss you. I will see you soon. Have a wonderful, wonderful, wonderful day and night and week. And I will see you soon. Bye, scholars.